What if the most terrifying object in our solar system is not dangerous at all, but so ancient that it was already drifting through the galaxy before Earth even existed? And what if two of humanity's greatest telescopes ended up proving that at nearly the same moment without anyone planning it that way? Before we go deeper, do me a quick favor. Like this video if you love real space mysteries, subscribe if you want smart stories without the nonsense, and share this with one friend who still looks up at the night sky. Most people heard about this object only after headlines started exploding online. Some posts called it terrifying, some called it unnatural. Some went even further and said this had to be some kind of alien probe. That is the version of the story that spreads fast. But the real version is better, because the real version shows us something much bigger than a scary headline. It shows us how modern astronomy is changing. It shows us how one telescope can accidentally catch a cosmic trespasser, while another can read its chemistry like a forensic report. And when those two pieces snap together, you do not just get a cool discovery, you get a time capsule from another part of the Milky Way. The official story began on July 1st, 2025. That was the day a survey system called ATLAS spotted something moving through the sky from Chile. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. Its job is to scan the sky and notice things that move. At first, what it found looked like one more technical entry on a long scientific list. It received the label C2025N1. But scientists kept checking the motion, the brightness, and the orbit. And very quickly they realized this object did not belong here. It was not looping around the sun like a normal resident of our solar system. It was slicing through, coming in from outside. Not from the asteroid belt, not from the Kuiper belt, not from some hidden corner near Neptune. From interstellar space. That changed everything. Once astronomers confirmed the orbit, the object got a new identity. 3 I's Atlas. The I stood for interstellar, and that one letter made the discovery historic. This was only the third confirmed interstellar object ever seen passing through our solar system. The third. In all of human history. Think about that for a second. And still, by mid-2025, we had only confirmed 3 objects that clearly came from somewhere beyond our own solar system. That is how rare this is. That is how small our window of opportunity can be. But here's where the story becomes far more dramatic. The official discovery did not happen at the true beginning. It happened in the middle. Because when researchers started digging backward through older images, they found something stunning. The new Vera Rubin Observatory had already seen this object 10 full days earlier. Not on purpose, not because anyone was tracking it, not because some scientist had predicted it. It had simply been there, quietly crossing the background of the sky, while Rubin was doing test observations. And nobody knew. The Vera Rubin Observatory was still in its science validation phase at the time. That means it was basically in a giant rehearsal. The system was being tested, the camera was being checked, the optics were being calibrated, the software pipelines were being pushed. This was the dress rehearsal before the 10-year survey that Rubin was built to carry out. So on June 21st, 2025, when the telescope captured images that happened to include the object, nobody looked at those frames and thought, we just found an interstellar visitor. They saw calibration work. Then came the discovery announcement from Atlas. Then came the rechecking. Then came one of those moments that makes astronomy feel almost cinematic. There it was, already sitting in the archive, already photographed, already recorded before the world knew to care. That means Rubin had unknowingly captured one of the earliest and clearest views of 3I Atlas on Earth. And the observatory kept recording it through July 20th, collecting close to 100 exposures, with dozens of those later used in a full scientific analysis. So before people online were making wild claims about the object, Rubin had already been quietly building a visual record of it, not through a dramatic chase, through pure chance. And chance like that does not usually happen unless your telescope is absurdly powerful. Rubin sits high on Cerro Pachon in Chile, where the air is dry and the skies are dark. But the real monster feature is the instrument itself. Its main mirror is 8.4 meters across. Attached to it is the LSST camera, the largest digital camera ever built for astronomy, capable of capturing an image with roughly 3,200 megapixels. That is not just impressive for a press release. Rubin can take huge swaths of sky and record them with incredible detail. It is built for speed, coverage, and repetition. It is designed to notice change. That is exactly why this accidental catch matters so much. If Rubin can stumble onto an interstellar object during testing, imagine what it can do during full operations. But those early Rubin images were not just important because they existed. They were important because they showed behavior. The object was not a dead rock. It was active. Scientists could see a coma forming around it, a cloud of gas and dust expanding as sunlight heated the object. During the observation period, that coma grew significantly because active comets behave like that. They warm up. Frozen materials turn into gas, dust gets released, A fuzzy envelope begins to build around the nucleus. That is normal comet physics, and that normal behavior immediately pushed the object away from the more dramatic internet theories. But Rubin also showed something that made scientists pause. The dust tail appeared to point toward the sun, not away from it. Now, if you have ever seen a basic drawing of a comet, you probably remember one rule. The tail points away from the sun. That is the usual pattern, because sunlight and the solar wind push material outward. So a sunward pointing tail sounds wrong. It sounds like the object is breaking the rules, and when people hear that, they start filling the gap with fantasy. But astronomy is full of situations that look impossible until geometry and physics explain them. In this case, researchers pointed to uneven dust release from the surface combined with viewing angle. The dust was not coming off in a perfectly even way. That can create strange-looking tail shapes depending on how the object is turned and how we are seeing it from Earth. And that is when the second giant in this story enters, James Webb. If Rubin is the sky scanner, Webb is the investigator. Rubin finds. Webb examines. Rubin notices motion across vast fields. Webb stares deeply at a target and tears its light apart molecule by molecule. These telescopes do different jobs. That is why their overlap on this object is so powerful. Rubin told scientists where the visitor was, how it looked, how it moved, and how its activity changed. Webb asked a deeper question. What is this thing actually made of? And once Webb asked that question, the entire story widened. On August 6, 2025, the James Webb Space Telescope aimed one of its most important instruments at 3I Atlas. That instrument was NIRSpec, short for near-infrared spectrograph. A spectrograph does not just take a pretty picture. It breaks light into patterns, and those patterns act like fingerprints. Different molecules absorb and emit light in different ways. So when Webb looked into the object's coma, it was not just seeing a fuzzy cloud. It was reading chemistry. It was asking what kinds of ice, gas, and compounds were being released from this traveler as it warmed near the sun. What it found was both familiar and extraordinary. Scientists detected carbon dioxide. They detected water. They detected water ice. They detected carbon monoxide. They detected carbonyl sulfide. None of those ingredients, by themselves, scream alien technology. In fact, they're exactly the kinds of materials scientists expect to find in comets. That matters, because, once again, the object was acting natural. Its chemistry looked like comet chemistry. Its coma looked like comet activity. Its orbit looked like interstellar motion. The big picture was becoming clearer. This was not a machine. This was not an artificial artifact. This was an ancient comet from somewhere else. But then came the part that made researchers lean forward. The ratio of carbon dioxide to water in the coma was extraordinarily high, higher than what had been recorded in any comet studied before, whether from our own solar system or from interstellar space. That does not mean the object was dangerous. It means it formed under conditions very different from the ones that shaped most of the comets we know. And in astronomy, ratios like that are gold, because chemistry is memory. A comet carries the conditions of its birth inside its ice. The balance between water, carbon dioxide, carbon monoxide, and other trapped compounds can tell scientists about temperature, radiation, and the region where that material first came together. So Webb was not just listing ingredients. It was reading a biography written in frozen matter. If this part of the story already has you hooked, hit the like button now, subscribe for more real cosmic deep dives, and send this video to the one person you know who loves space but hates clickbait. On October 29th, 2025, 3I Atlas reached perihelion, the closest point in its path around the sun. That is when solar heating can really wake a comet up. Ancient ice begins turning to gas faster. The coma can brighten. More material gets thrown into space. And for astronomers, that means the object can become even more revealing. A more active comet gives off more signals, more gas, more dust, more clues. After that close solar pass, Webb looked again on December 22nd, 2025, following the object's closest approach to Earth on December 19th. Even then, the object was still nowhere near dangerous. It passed at a safe distance of about 270 million kilometers, or roughly 168 million miles. So if you saw videos screaming that this thing was coming for us, that was fantasy, not science. At no point did 3I Atlas threaten Earth, not even close. What it did threaten was our sense of scale, because the deeper Webb looked, the more unsettling the real answer became. In that later round of observations, scientists measured isotope ratios inside the comet's material, including ratios involving carbon and deuterium, sometimes called heavy hydrogen. This is where the story jumps from exciting to almost surreal. Those ratios did not match the patterns typically seen in comets formed within our own solar system. That mismatch is not a small technical footnote. It is the fingerprint of another birthplace, a different environment, a different chapter in the history of the galaxy. To understand why that matters, imagine finding a bottle floating in the ocean. You do not know where it came from, but the glass, the salt marks, the label, and the material inside all tell a story about where it was made and how long it has been drifting. That is what Webb was doing with this comet. Only the ocean was the Milky Way, and the bottle had been floating for billions of years. The deuterium ratio matters, because deuterium forms and survives differently under different cosmic conditions. The same is true for the balance of carbon-bearing molecules. Over vast timescales, as generations of stars live and die, they change the chemical makeup of the galaxy. That process is called galactic chemical evolution. So an object born very early in the Milky Way can preserve a different chemical signature from one formed much later. That gives astronomers a way to estimate not only where an object might have formed, but also roughly when. And that estimate was staggering. Based on Webb's analysis, 3I Atlas may have formed around 10 to 12 billion years ago in a cold and distant region of the early Milky Way. Our solar system is about 4.6 billion years old. Earth is about 4.5 billion years old. That means the ice in this object may have existed billions of years before the sun was even born, before Earth had oceans, before our planet had continents, before there were dinosaurs, trees, insects, or oxygen-rich skies, before there was anything here at all. This object may have been ancient when our solar system was still just a cloud. That is the part I think really deserves the word terrifying. Not because it is hunting us, not because it is artificial, but because it reminds us how late we are, how young our world is, how long the galaxy was already in motion before we arrived to notice it. And yet, that is exactly why this discovery is so beautiful. Because a species that did not exist when this comet formed has now built instruments precise enough to catch it in passing and decode its origin. That is one of the most human things imaginable. We are small, yes, but we are not blind. We can look up, we can measure, we can understand, slowly, partially, but really. That is what makes this whole story feel almost emotional. It is not just about an ancient object. It is about a young civilization learning how to read ancient things. Of course, none of that stopped the alien probe claims. That speculation was almost guaranteed. The moment people hear interstellar object, memories of Oumuamua come rushing back. Back in 2017, Oumuamua became famous because it was weird, fast, and hard to explain in real time. Its shape looked unusual. Its motion sparked debate, and because the object was discovered after it had already passed its closest point, astronomers had limited time to study it. That left gaps. And wherever there are gaps, the internet pours in its own answers. Then, in 2019, came Borisov, the second confirmed interstellar object. Borisov behaved much more like a familiar comet. It had a coma, it had a tail, it fit comfortably into known physics. Now, 3I Atlas arrives as the third confirmed case, and in many ways, it gives scientists the best combination yet. A truly interstellar path, strong comet activity, early images, and detailed chemical follow-up. It is rare, but it is readable. That makes it priceless. Its orbit is one reason astronomers are so confident about its origin. 3I Atlas has a highly hyperbolic trajectory. That means it is not on a closed orbit around the sun. It is not bound here. It came in fast, swung through, and is heading back out. Scientists describe orbit shapes using a number called eccentricity. If that value is less than 1, the orbit is closed. If it equals 1, you are right on the edge. If it is greater than 1, the object is on an open path and will not return. For 3I Atlas, that number is about 6.14. That is extremely high. It is a giant neon sign saying this thing does not belong to the solar system. Its speed told the same story. As it approached the inner solar system, it was moving at roughly 221,000 kilometers per hour, or about 137,000 miles per hour. That is not ordinary neighborhood traffic. That is a deep space fly-through. Researchers also estimated something called its kinematic age, which is basically a way of asking how long it may have been traveling through interstellar space. Those estimates landed in the range of roughly 3 to 11 billion years. That range lines up surprisingly well with the chemistry-based age clues from Webb. And when two different methods point in the same general direction, confidence grows. That is a big part of why the story matters. Not because one telescope said something wild, but because multiple lines of evidence started agreeing. Rubin's images, Webb's spectroscopy, orbital analysis, later supporting observations from other instruments. This was not one dramatic claim hanging by a thread. It was a case being built piece by piece. Even the size of the object had to be estimated carefully. Observations from Hubble helped put the nucleus somewhere in a broad range, from a few hundred meters up to several kilometers across. That range may sound frustrating, but it makes sense. An active comet hides its solid center inside a bright cloud of gas and dust. Trying to measure the exact body inside that blur is difficult, even with our best telescopes. It is like trying to judge the size of a light bulb while staring into the glow around it. Still, even with uncertainty, researchers could tell this was no tiny speck of dust. It was a substantial object carrying ancient material across the galaxy, And the more scientists looked, the more this became a team effort across astronomy. Hubble took observations. NASA's Sphere-X mission added infrared data. TESS, a mission better known for studying planets around other stars, was also used to help examine the comet's behavior and rotation. Even ESA's JWST spacecraft, on its long journey toward Jupiter, managed to capture an image while the geometry happened to work out. That is one of the most amazing parts of modern science. A rare object appears, and suddenly instruments with totally different original missions begin contributing pieces to the same puzzle. Different eyes, different wavelengths, different positions. One story, and that brings us back to the title question. How did James Webb and Vera Rubin confirm the same terrifying object? Not by making the same measurement, not by copying each other, and not by chasing a fake mystery. They confirmed it by doing two different forms of truth-telling. Rubin confirmed the object as a real, active, trackable visitor through repeated imaging. It showed the coma. It showed the early timeline. It showed the unexpected tail shape. It showed that the object had been there before the official discovery even went public. Webb confirmed what kind of visitor it was through chemistry. It showed the molecules. It showed the unusual ratios. It showed that the object's material likely came from a place and time far outside the story of our own solar system. Same object. Two different kinds of confirmation. One visual, one chemical, one wide field, one deep focus. Together, they turned a moving dot into a cosmic biography. Quick pause before we go to the final layer. If you want more videos that separate real science from viral noise, subscribe right now, tap like so YouTube knows this is worth sharing, and send this to someone who loves space facts that actually hold up. Now think about what that means for the next few years. The Vera Rubin Observatory officially began its 10-year legacy survey of space and time on June 30th, 2026. That survey is built to scan the sky over and over again, catching anything that changes, moves, flashes, or suddenly appears. Asteroids, supernovae, variable stars, comets, and very likely more interstellar visitors. If Rubin caught one of the most exciting objects in modern astronomy by accident during testing, that is not just a cool coincidence. It is a preview, a hint, a warning almost, that the next decade of astronomy may be full of objects we have never seen before. Not because the universe suddenly changed, but because our ability to notice it just took a huge leap forward. That is the deeper revolution here. For most of history, the universe revealed itself only when something bright or obvious happened. A comet became visible to the naked eye. A supernova lit up the sky. A planet moved in a pattern people could track. But now we are entering an age where the sky is monitored constantly, systematically, with machines that do not get bored and archives that do not forget. That changes discovery itself. The big find is no longer only the thing you point at on purpose. Sometimes it is the thing sitting quietly in the data, waiting for the right question to be asked later. That is exactly what happened here. Rubin did not know it had captured history when the shutter clicked. History was only recognized afterward. That is a very different future for science. And James Webb completes that future in the best possible way. Rubin can find the surprise. Webb can interrogate the surprise. Rubin can say, something unusual is here. Webb can say, here's what it is made of, how it behaves, and what that tells us about where it came from. That partnership is incredibly powerful. One observatory sweeps the stage. The other brings the spotlight. One makes sure the universe cannot hide movement for long. The other makes sure the movement is not just seen, but understood. 3i Atlas may be the first famous example of that partnership in action. It will almost certainly not be the last. This is why I think the alien probe framing actually makes the story worse, not better. It shrinks the wonder. It replaces evidence with fantasy. At the exact moment when reality is already astonishing. Ask yourself which idea is truly bigger. That this was some sci-fi machine with no evidence behind it? Or that a natural comet formed 10 to 12 billion years ago in another region of the galaxy, drifted alone through interstellar darkness for ages beyond human imagination, and happened to cross the path of a young technological species just as that species built the tools needed to understand it? To me, the second idea is far more powerful. It is eerie in a deeper way. It says the galaxy is full of history we have never touched, and every once in a while a fragment of that history passes close enough for us to read a few lines. There's also something humbling about how accidental part of this was. Scientists work hard. They plan missions. They build instruments with absurd precision. They develop models, pipelines, and survey strategies. All of that matters. But then a discovery like this reminds us that luck still has a seat at the table. Rubin was not hunting 3i Atlas on June 21st. It was testing. It was checking itself. And the object just happened to be there. That is almost poetic. The universe did not send an invitation. We just happened to be looking in the right direction at the right time. And because we were ready, chance became knowledge. Now imagine the opposite. Imagine this object passed through the inner solar system a century ago. No Rubin, no Webb, no Hubble follow-up, no infrared spectroscopy, no global network ready to compare data in real time. It might have been missed completely, or maybe someone would have seen a faint blur and never known its true origin. The object would still be ancient, it would still be interstellar, it would still be carrying the same frozen history, but humanity would not have known. That thought is worth sitting with. The universe has probably been sending messages like this for a very long time. We are only now becoming capable of opening them, and that is why the word confirmed matters so much in this story. Not guessed, not hyped, not exaggerated, confirmed. Rubin confirmed that the object had been there early and that it behaved like an active comet. Webb confirmed the chemistry that tied it to a very old and very foreign birthplace. Other instruments confirmed supporting details across different wavelengths and methods. This is what real science looks like when it works well. Not one genius making a dramatic speech, but multiple teams, multiple tools, multiple kinds of evidence, gradually narrowing the possibilities until the most solid explanation rises above the noise. That process may look slower than a viral rumor, but in the end, it is stronger and more beautiful. If this story changed the way you think about what's drifting through our galaxy, share this video with another curious mind, hit subscribe so you don't miss the next real discovery, and drop a like if you'd rather have wonder backed by evidence. Right now, 3i Atlas is already on its way back out. Its closest pass is behind us. The best observation window is gone. It is fading into distance. Soon it will become too faint for practical study, and then it will return to the dark between stars. Maybe forever, at least as far as human observation is concerned. This was a one-time encounter, a brief crossing, a cosmic near miss with knowledge attached. We do not get to call it back. We do not get a second pass next year. We had one chance to learn from it, and by all measures, scientists used that chance extraordinarily well. And what remains is the record. Images from Rubin, spectra from Webb, support from Hubble, SphereX, TESS, JWST, and others. Orbital solutions, chemical ratios, papers, models, debates refined by data. And behind all of that, a simple, haunting truth. This object may have begun forming when the Milky Way was still young. It may have spent billions of years in silence before entering our neighborhood. It carried a history older than our sun. Then, for a tiny moment in cosmic time, it became visible to a civilization that had only just learned how to truly see. That is why this object matters. Not because it was a threat, not because it was an alien machine, but because it was real evidence from another place and another age. A physical sample of galactic history delivered to our doorstep by gravity and time. And because two very different observatories, one on a mountain in Chile and one far out in space, were ready to tell its story from two different angles. Rubin showed us the visitor, Webb showed us its past. Together, they gave us something close to impossible, a look at material that may be billions of years older than the world we stand on. So maybe the most terrifying part is not the object itself. Maybe it is the perspective it forces on us. The reminder that the universe is not just big, it is old beyond instinct, patient beyond language, and full of travelers whose journeys began long before we had names for stars. 3i Atlas did not come here to scare us. It came here by chance. But for one brief moment, it allowed us to see how enormous the story really is. And once you feel that scale, once you realize that a lump of ice and dust from another era of the Milky Way can drift past Earth and be decoded by human minds, the universe stops feeling empty. It starts feeling ancient, alive with history, and far stranger than fiction ever needed it to be.